Hello everyone. Today we will start numerical solution of algebraic and transcendental equation. So in this chapter we will discuss today Newton-Raphson method. So first is introduction. So what is Newton-Raphson method? This is an iterative method and it is used to find isolated roots of an equation f(x) equal to 0. The object of this method is to correct the approximate root x0 successively to its exact value alpha. Initially, a crude approximation small interval a0 b0 is found out, in which only one root alpha, say, of f(x) equal to 0 lies. Let x equal to x0, x lies between a0 to b0, is an approximation of the root alpha of the root of the equation f(x) equal to 0. Let h be a small correction on x0. Then x1 equal to x0 plus h is the correct root. Therefore, f of x1 equal to 0, that implies f of x0 plus h equal to 0, equation 1. Therefore, by Taylor series expansion, we get f of x0 plus h into f dash x0 plus h square by factorial 2 f double dash x0 plus h cube by factorial 3 f triple dash x0 plus dot 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 equal to 0. As h is very small quantity, neglecting the second and higher order powers of h, an approximate value of h is obtained as f of x0 plus h into f dash x0 equal to 0. That implies h equal to minus of f of x0 divided by f dash x0, providing f dash x0 not equal to 0. This is equation 2. From equation 2, a value of h is obtained, which gives, when added to x0, a better value of the root. If this improved value of the root is x1, then x1 equal to x0 plus h. So x0 minus, just putting the value of h from this one, x0 minus f of x0 divided by f dash x0. This is equation 3. So further, h1 be the correction on x1. Then x2 equal to x1 h1, equation 4, is the correct root of fx equal to 0. That implies f of x2 equal to 0. F of x2 means x1 plus h1 equal to 0. Again we are applying the Taylor series expansion, then neglecting the higher order powers of h1. So f of x1 plus h1, f of x1 equal to 0. h1 means minus of f of x1 divided by f dash x1. Again providing f dash x1 must be not equal to 0. This is equation 6. So from equation 6, a value of h1 is obtained, which gives, when added to x1, a better value of the root. If this improved value of the root is x2, then x2 equal to x1 plus h1. So that means x1 minus f of x1 divided by f dash x1, which is coming from this one. So proceeding in this way, we get n plus 1th corrected root as xn plus 1 equal to xn plus hn. So that implies xn plus 1 equal to xn minus f of xn divided by f dash xn, which is equation 8. So the formula 8 is known as the iteration formula of Newton-Raphson method. The number of iterations required depends upon the desired degree of accuracy of the root. Okay, so this way we can develop the formula of Newton-Raphson method. Next is advantages and disadvantages of Newton-Raphson method. Advantages are, the convergence of the method is faster as the rate of convergence is quadratic. Disadvantages: number 1, Newton-Raphson method fails when f dash x equal to 0 or very small neighborhood of the root. Thus, this method is not suitable in those cases where the graph of fx is nearly horizontal while crossing the x-axis. And number 2, initial approximation should be taken very close to the actual root. Otherwise, the method may divert. Next is criteria for convergence in Newton-Raphson method. In Newton-Raphson method, this is the formula. This is really an iteration method where xn plus 1 equal to phi xn and phi xn equal to xn minus f of xn divided by f dash xn. Hence the equation x equal to phi x, where phi x equal to x minus fx by f dash x. So the sequence xn converges to the exact value if mod of phi dash x less than 1. So mod of x means just here mod of phi x equal to this one. So here after derivating this one x derivation of x is 1 minus of f double dash x, this is u by b formula, f dash x whole square. So in numerator we have f dash x whole square minus fx into f double dash x. So after simplifying, what we have, modulus of f dash x whole square greater than of fx into f double dash x. This is also in modulus. So this is the criteria for the convergence, and then in an interval containing actual root alpha should be selected in which equation 9 is satisfied. Next is geometrical interpretation of NR method. So here is the geometrical interpretation. We draw the graph of the curve y equal to fx. So this is y equal to fx, this one. With respect to the ox and oy as axis. Ox and oy as axis. Let the tangent at P and Q. Let the tangent at P and let the tangent at P0. P0 meets the x-axis at A1 here, where OA1 equal to x1, and the tangent at P2 x2 f of x2 meets the x-axis at A2, this one, where OA2 equal to x2 etc. Thus A0 P0, A0 P0, this one. Thus A0 P0 equal to A1 into A0 into tan of angle of P0 A1 A0, this angle, equal to A1 A0 into f dash x0. So f of x0 equal to x0 minus x1 into f dash x0. So x1 equal to x0 minus f of x0 divided by f dash x0. So thus it is clear that the successive approximations of the root, that is x1, x2, x3 dot 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 xn plus 1, are obtained respectively by the points at which the tangent at x0, x1, x2, x3 up to xn to the curve y equal to f of x meet x-axis. Next is rate of convergence of Newton-Raphson method, or estimations of error in Newton-Raphson method. If xn plus 1 be the n plus 1th approximation of the root alpha of fx equal to 0 and epsilon n plus 1 be the corresponding error, we have alpha minus xn plus 1 equal to epsilon n plus 1. This is equation 1, and xn plus 1 equal to xn plus hn, or alpha minus xn plus 1 equal to alpha minus xn minus hn. So this one we can write epsilon n plus 1, and this one we can write epsilon n minus hn from equation 1, this one. So epsilon n equal to epsilon n plus 1 plus hn, equation 2. We know that hn equal to minus of xn divided by f dash xn, minus of f of xn divided by f dash xn. So after cross multiplying, what we have, f of xn plus hn f dash xn equal to 0. Again we have alpha equal to xn plus epsilon n. So f dash alpha equal to 0. That means f of xn plus hn, f of xn plus epsilon n. So after using the Taylor series expansion, this one, f of xn plus epsilon n f dash xn plus epsilon n whole square factorial 2 f double dash phi n. So pi n lies between xn to alpha, neglecting the higher order terms of epsilon n. This is equation 4. Now subtracting 3 and 4, what we have, epsilon n minus hn into f dash xn plus epsilon n squared by factorial 2 f double dash pi n equal to 0. So then we have this one, we can write epsilon n plus 1 f dash xn plus epsilon n squared by factorial 2 f double dash pi n equal to 0. So now taking both side modular sign, what we have, modulus of epsilon n plus 1 by epsilon n square equal to half of modulus of f double dash pi n divided by f dash xn. So if the iteration converges, that is xn and pi n tends to infinity as n tends to infinity. So what we have, limit n tends to infinity, modulus of epsilon n plus 1 divided by epsilon n square equal to half of f double dash alpha divided by f dash alpha. So now putting the value of this, so limit n tends to infinity, modulus of alpha minus xn plus 1 divided by alpha minus xn square. This equal to half of f double dash alpha divided by f dash alpha. So thus it is clear that Newton-Raphson iteration method is a second order iteration process. Therefore, the iteration process converges very rapidly with constant asymptotic error equal to half of f double dash alpha divided by f dash alpha. So hence the convergence is quadratic. This is very important. Rate of convergence is quadratic, or error of convergence, or show that order of convergence is quadratic. So these are very important. Answer will be same. Next, regarding one example, find the smallest positive root of the equation 3x cube minus nx square plus 8 equal to 0. Correct to 4 decimal places using Newton-Raphson method. So fx equal to 3x cube minus 9x square plus 8, f dash x equal to 9x square minus 18x. So here interval is not given, so we have to use from the, since we are going to find smallest positive root, so here we have taken from 0. At the point 0, this is showing positive value. At the point 1, this is showing positive value. At the point 2, it is showing negative value. So root lies between 1 to 2. So since in our formula we require derivative, so here f of xn and f dash xn. So by Newton-Raphson method, this is a formula. So xn plus 1 equal to xn minus f of xn, already we know, f dash xn, that is derivative also we know. This is equation 1. Now from equation 1, we are putting n equal to 0. We are putting n equal to 0. So that means x1 equal to x0 minus 3x0 cube minus 9x0 square plus 8 divided by 9x0 square minus 18x0. So put the value of x0. First x0 value will be 1. So since the value 1, so you will put the value. So you will get 1.22222. So here next is x2, that means putting n equal to 1. So in place of x0 it will be x1. So now x1 will be this. So always we will put the update value. So x1 into this. So 6 into x1 cube minus 9 into x1 square minus 8. 9 into square minus 18 into square into this. So we are having this one. So this is x2. So next is x3. So x3 is same way. This is x2. So when we are going to find x3, we will put the update value of x, that is x2. So now the question is up to how many terms it will go. So depend on the answer, that is 4 places of decimal. So 4 places of decimal. So just see that already I told you, when the last two iteration difference is very small, we can stop our process. So here 4 places means we have to check 5 places decimal, 4 plus 1. Okay, so here at the point x2, at the point x3, both are same, so we can stop here. So your answer will be, since we are having 4 decimal places and we have to check 5 decimal places, so 1 2 3 4 5, 5 is greater than 5 decimal places is greater than 5, that is 7. So the previous one increased by 1. So that's why result is 1.62, 1.2261. Next, another example. Find the root of the equation e to the power x 2x plus 1 correct to 4 decimal places using Newton-Raphson method near x equal to 1. So it is given near x equal to 1. That means at the point of x we will start. So same way, this is your given function, and f1 equal to minus value, f2 equal to positive value. So root lies between 1 to 2. Now same way we are having the Newton-Raphson method, and we have to using the formula develop the functional value. And here for quick convergence, just see that here it is given Newton-Raphson method near x equal to 1. So we can easily start from equation x equal to 1. But for quick convergence, we choose x0 equal to 1.5. So this type of assumption you also take, because it is near x equal to 1. So 1.5 we can easily take. So here after the calculation, this is your calculation part, you will solve at home and you will find out the 4 decimal places answer will be 1.25906. So since here 4 decimal places, so we have to correct up to, so it will be answer will be 1.2591, because fifth element is greater than 5. Okay. Next is using Newton-Raphson method formula, establish the iterative formula xn plus 1 equal to half of xn plus capital N by xn to calculate the square root of n. Okay, so here function is not given, so you will develop function yourself. So square root of n, it is the hint is given, so x equal to root over of n, so taking both sides square, x square equal to n, so x square minus n equal to 0, and just see function is x square minus n and derivative is 2a. So we have to develop the functional value, that is Newton-Raphson method. So this one, so after using this taking common half, so you will get this type of result. Okay. Next is same way we will find out another problem. Find cube root of 10 up to 5 significant figure by Newton-Raphson method. So cube root of 10 means n equal to this. So both side cubing, x cube minus 10. So function is x cube minus 10. Derivative minus 3x square. Since there is no interval given, so we will start from 0. F0, F1, F2, F3. Just see here all values are minus values. So we have to take until the opposite value we will get. So the C, so root lies between 2 to 3. So Newton-Raphson formula, we develop the function. So hence we have, so after calculation you will find out 2.1544 correct up to 5 significant figures. Okay, table formation you will find out yourself. Okay, this is the calculation. Here we skipping the table, you have to find the table yourself. Next is using Newton-Raphson method, obtain iteration formula for the reciprocal of number n, and hence find the value of 1 by 22 correct to 3 significant figures. So here x equal to n we are putting, because here it is given reciprocal of a number n. So reciprocal means 1 by n. So n equal to 1 by x. So 1 by x minus n equal to 0. So function is 1 by x minus n. Function value, that is derivative value, is minus 1 by x square. According to the formula, we will develop this result 2 minus n xn into xn, where n equal to 1 to 2. As the value 1.22 lies between 1.20 to 1.25, so between that means 0.04 to 0.05. So we take n equal to 22 and x0 equal to 0.04. And the required value of 1 by 22 is 0.05 0.4545 correct to 3 significant figure. Here also I am skipping the table. You will find yourself same as before. Just calculate the 1 by 1 iteration, and whenever last 2 iteration, when the result of the root is very minimum, difference is very minimum, we can stop our process, and the last one will be your result. Okay. Now these few questions are given, you will solve at home. This is your practice set. So students, next day we will start another topic. Okay, so till then, bye all of you.